Yo, what is up, guys? Welcome back to another video. Like I told you guys, man, we're going to be ramping up the video production this time around, and we couldn't be happier to do it. Honestly, without the viewership, it's like anything else, it's like a TV show. We couldn't do it without you guys, man. I mean, we're starting at 0 and now we're approaching 800 subscribers. Every time I talk to you, it's a few more people, right? We just got to get this thing sitting on a launch pad and let it take off. And it takes you guys, the viewers, to share the shows with everybody, share the information. If you think you're getting something from it, we really do appreciate it, man. You hear me tell you that, guys, this every single time. This time is no different. If you're new to the channel, man, please subscribe to the channel. Smash that like button. Helps us out tremendously, and we're grateful every single time you do it. For those of you that have been here, that have watched our videos, continue to watch our videos, comment on our videos, spread love in the videos. Can't begin to tell you how much I appreciate it. We almost creating like a little bit of a community here, and it's a lot of fun to see this thing go and grow and build. So thank you. We couldn't do it without you, and we're just going to continue to pump and continue to grow the channel and share what some of us love. I know I do, and that's why I come on here and talk to you guys about these things all the time. On this episode, man, I really wanted to, I had an experience the other day. And you guys have heard me talk about engineers, and you've talked about different manufacturers and how they build things and how they go through their process and how they, figure out how they're going to do something. And I had like a silly situation the other day with a Lochinvar AWN 1300. Now, from my understanding and from at least what I can see, the AWN series is probably a little bit older. I think the boiler we were working on was approaching the 10-year mark, which in hindsight for a condensate boiler is pretty freaking good, right? From what I've seen, shelf life on these things, I guess, is debatable as long as you're servicing them. We have been servicing them for quite a while. But we had a specific problem on a job, and I wanted to come on here and discuss it with you. Now, I want to discuss the simplicity of the problem itself and give you guys a little bit of guidance in that department, but I also want to talk about the ridiculousness of design. Now, I understand some things get designed, and maybe this was an initial design, and they had to go back to the drawing board. That I can understand. Listen, even as a technician, sometimes we do things one way, then you meet with somebody or you see an easier way to do it and you learn how to do it easier. This happens. I understand. I'm not on it. I have a lot of love for engineers. I just have always felt in my heart that real job experience should be necessary for somebody to complete, their education. Now, I could be wrong about this, right? But if I'm the one designing equipment, shouldn't I fully understand and grasp exactly what it's going to take to fix something on a location? Because let's be real, these guys that do get to see the equipment, or even the people that manufacture it in a shop somewhere, it's a clean shop, it's a perfect environment, the air temperature, the humidity, all the things are perfect for the electrical purposes and everything else. Now, let's talk to technicians, because I assume the majority of you guys that follow us, subscribe to our channel, are more on the tech side, the plumbing side, or even if you just are in the space somewhere adjacent to what we're doing and you like to watch my videos, let's be honest about something. 99.99999% of the time, there is no perfect situation, right? The floors are dirty, the room has no lighting, the floor is uneven, there's no ladder. We can go down the list of a million things that don't exist inside of a boiler room. And so somebody who takes a perfect scenario and perfect conditions can do anything they put their mind to. I can put my mind to it and fix anything if I'm under the perfect conditions. But in a scenario where I'm not in the perfect conditions, which is the majority of our jobs, why is it you design some equipment to make it nearly impossible to fix? So now I digress, and I'm going to discuss you with what happened, and I'll give you a little education on it as well. On the AWN series Lochinvar is a condensing boiler, but the 1300 is basically two smaller AWNs on top of each other, and we have two of these units, 1.3 million BTUs side by side, so 2.6 million BTUs. There's a multitude of different sensors, as I know some of you guys already know, just from working on higher efficiency equipment. We have flow controls and all types of different high limit sensors and whatnot. The boiler is also fixed with what's called a hex switch, or I call it a high limit, but it's not a high limit manual reset. It has a thermistor inside. I correct me if I'm wrong, but basically it has like a little thermistor inside, similar to how a rollout switch on a simple gas boiler would be. Once it burns up, it's no longer in use. It can't be, and it's a safety for the boiler. So the hex switch on the Lochinvar AWN series is in the back side of the chamber. So if you were looking at the back of the boiler, this would be the back, the switch would be here, and then right on the other side, if you could see through it, would be the refractory. It's a circular, maybe 6 inches, and it has a simple screw that goes through the middle. And then just like any other refractory, as time evolves and overhauls are done, or overheating is done, or just consumption of usage, they start to deteriorate. And the thickness of the refractory is only about a 3/8 of an inch. I don't even think it's even a 1/2 inch. It's about 3/8 of an inch. But let's call it a 1/2 inch for round numbers. And when they crumble, it exposes the rear part of the boiler, which is a simple aluminum structure. There's really nothing to it. And it's very easy for it to melt and concave and create problems. So they created this hex switch that when that happens and overheating occurs in the rear of the boiler, that thermistor basically breaks and the power to the boiler stops. The power is shut to the boiler, but it will go into a safety, and you cannot get the boiler out of safety to operate without replacing the switch. Now, also, even if you just change the switch, if you don't take care of the initial problem, which is the refractory, guess what? You just burn another switch. And on top of burning another switch, you run the risk of a meltdown in the back of that boiler. It is not a thick metal that can resist the heat of the chamber. Even though the chamber doesn't get as hot as a typical boiler that we work on, but even on the high efficiency side, if we're getting into the 500 or slightly over 500 degrees in the chamber, and that runs for even a minute or two, you run the risk, and I'm not saying it would happen, but you run the risk of a meltdown. And here's even another layer that I learned while on the job, is that this particular model, they no longer make it anymore. So even though only one of 2 boilers technically go bad, I have to change the entire unit to replace the problem. And then that has its own other set of issues that we're not going to discuss on this video. But with all that being said, when you go to take out this old refractory, right? Because even if it's crumbled and I can reach in there somehow and pull out the old stuff, I want you to picture this, okay? Now, this is the upper unit of the 2. There's a lower and an upper unit. So the upper unit's probably about, let's say 4 feet off the ground, 5 feet off the ground. And the depth from where the gun of the boiler sits to the back side of the boiler is probably somewhere in the range of about 3 feet long. I don't know the exact dimensions. That's not what this video is about. If you want the exact dimensions, the AWN 1300, go look it up online. But there's a tiny little screw on the other side that holds the refractory. Now, I want you guys to picture also for a second, the depth is about 3 feet long. So my arm, if I measured it, probably isn't even 3 feet long. And even if it was, which I can tell you from the experience I just had because I was on the job, trying to reach your arm in, and the unit is up against your shoulders. So even if you can touch the screw, you really can't get a good grip on the screw to remove it. And it's so, from overheating and overheating and overheating and overheating, overheating over and over and over again, it really gets stuck in there. Now, normally, under conditions like that, we might take a torch, heat it up to open up the part that the screw is sitting inside of. But obviously, with a 6-inch round hole, you really have no place to put a torch, so it really limits your abilities. Now, we came up with some different concoctions, and one of my guys came up with some 1/2-inch copper pipe that he was able to put on the handles of a needle nose plier. You know what I mean? So they're like 4 feet long, so you could try to use it and maneuver it. In the end, it took one of my guys with longer arms that's a little bit taller, a little more lanky. Actually, it was my son, and I'm super proud of him, by the way. Went in there with a vice grip, got a good hold on it, spun the thing out, and miraculously, after about almost 3 hours of attempts between myself and 4 other people, finally got the out. So yeah, on one hand, you could say, bravo, right? Cheers to us, we did get it out. And we did. And I was super happy about it. And it definitely made our lives easier because I was already on the phone with the manufacturer figuring out how I could reinstall the new refractory without the screw, being that the screw was stuck in there. Now, he told me when all was said and done that they did recreate the refractory that comes with spring loaded, so it's like on multiple angles, so as you push it in, it can't pop back out. But that was not something I had at my disposal, and that was going to take, you know, probably a month or two to get. So I had to make sure the building had hot water. Again, that's what we do, right? At the end of the day, our job is to problem solve and figure out what we're going to do, how we're going to fix an issue, how we're going to overcome problems, and then tackle it and then bring a solution to the table. So on this one, thankfully, after all this time, because we stuck with it, because I knew that I wanted to install this thing the right way, we got the screw out, we were able to slide the new refractory in, put the new screw in, and everything worked out perfectly. And it's raised a lot of conversation for me on all my other social media platforms. I like to ask different techs what they do in those situations, how do they tackle them. Again, this unit is about 10 years old probably, or at least on the cusp of 10 years old. I don't know what the shelf life is on these things. Some guys say 10 years, some guys say 15 years, some guys say 20 years. I take it like anything else. You know, it's like a regular boiler to me. People ask me how long it lasts. Well, how much maintenance are you willing to do? Are you staying on the upkeep? Are you making sure everything's operating the way that it should? And are you being diligent about the equipment you're working on? At the end of the day, if you do those things and you make sure everything's working the way it's supposed to, it should carry you for a long period of time without really having any issues. But I still digress and don't understand exactly why they would design something like this. Even in the beginning, like, I know the manufacturer told me they eventually changed and came up with this spring-loaded refractory wall so you could just slide it in and those springs would hold it in place. But how even initially when you're building this thing do you think to yourself, oh, this screw is going to be a fantastic idea and it'll stay in place? Now, what it will do, once you catch the screw and you get it in there nice, is it should stay. Like, it's not going to come down. I don't have to worry about it falling, because that was one of the things I was worried about. You know, I had thought about putting high heat silicone and trying to push it to the back wall, but then after discussions and realizing that silicone's going to dry and then taking the temperature of the chamber into account, you got to remember, man, you're still dealing with heat. So the question is, when you do something like that, like if you're going to push in a refractory and you cannot catch the screw and you're going to do it with a high heat silicone, you have to make sure your silicone's rated for the temperatures you're going to deal with. Now, knowing that my chamber temperature is probably going to be somewhere in the 500 range, like I said earlier, even slightly higher, I had a high heat silicone but only went up to 500 degrees. So what happens when it crosses the 500 degree barrier? And I've had this happen to me before, where I thought I caught the screw or whatever on other units and the thing fell down and then the hex screw goes again. We're battling this thing back and forth. And every time you change that hex switch in the back, it's really not a good thing for the unit. Eventually, on some of the older units I had, not this unit, but on another unit I worked on, eventually the heat exchanger did crack and we ended up having to replace it. Now, majority of that was because they didn't really do overhauls when they were first installed. I started doing them when I first took over the account, but this was already 6 years in. And anybody that knows condensing boilers, if you don't do service on them 6 years, you've already done a lot of damage to that unit. So again, I digress. I just wanted to talk to you guys about this because, well, first of all, I couldn't find really any videos talking about this very topic, especially the refractory, because as much as there are a lot of moving parts inside of these things, the refractory is like the most important thing, because if that refractory falls down and you allow this unit to work, you're going to kill the whole unit. So it's probably one of the most integral parts of the boiler and important to make sure that you have secure. And then trying to take it out, some things that you can do. Like I said, on this particular model, we finally were able to get a vice grip. That's my opinion. If you had one in there for a long time and it's stuck, vice grip's probably your best option. Obviously, the first thing we tried is we had the extension that they give you with the little cleaning tool. And I was able to find a bit for it. And we were able to get the thing in there, catch the bit, and try to spin it. But because it was so locked in there from overheating and whatever over time, it stripped out. And then we were just down to different options. But the first thing you obviously want to try is to get a bit down there and try to remove the screw as best you possibly can. You know what I mean? At the end of the day, it's our business to make sure that we make the job easier, not harder. You're trying to make your life easier, not harder. I wasn't anticipating 3 hours of screw removal, but that's what it ended up being. Now, you could use this lesson in many different scenarios, and I still question how somebody designs something. And it always leads me to believe that the person who's designing it, even though they have the best intentions at heart, when you don't physically understand it, see it, touch it, feel it, work on it, the result's always going to be the same. Now, I get it, it'll take some, now who knows, the newer models, maybe they're updated or done better, and, some of them are downfired as opposed to, this one's, the gun goes in this way, not from the, top down. But still, you would have the same issues if your design is has flaws. So, anyway, I ranted for a while on this one. It's a very frustrating topic. I'm sure a lot of you guys understand what I'm saying. And I was focusing more on the Lochinvar AWN series. They're all kind of built the same way. Just some are bigger, some are smaller, some are a little easier for maintenance, some a little harder. But the issues are really the same across the board. So if you've had this situation, man, please drop a comment below. Let me know how you overcame it. Let's keep these conversations going. If you guys know anybody that could gain something from these videos, man, share them, man. I mean, we're here for each other. I want to help you guys grow. I want to help you learn. And by all accounts, I don't know everything. I know a lot of things about a lot of things, and those are the things I try to come on here and talk about. But I want to hear from you guys some other ideas, some other thoughts on some videos you'd like me to do, because we're always like throwing ideas around, and I love hearing from you guys. It really helps me grow the channel and helps me help you a little bit where I can. So I appreciate you guys. If you haven't already and you've watched this far into the video, please subscribe. Once again, man, smash that like button. It's greatly appreciated. And for those of you guys who watch it through to the end, I know some of you always do, man, I really can't begin to tell you how much I love and appreciate all the support you give and the little conversations that we have going on in the comments. I've always answered. It's always me. It's not some robot or some other person. It's me answering. I love talking with you guys. I appreciate you guys so much. I hope you keep killing in your business. Have an amazing day. Peace.